Inshallah, in today's class, we are going to do few questions based on Stokes theorem. What is Stokes theorem? Actually, it is the transformation between line integral and surface integral. It is the transformation between line integral and surface integral. Now, if you see, let me see the statement of this. Let S be an open surface bounded by a closed, non-intersecting, simple curve C. If f is any differentiable vector point function, then now you have to by heart this formula. Line integral f dot dr over c equals to surface integral curl f dot n into ds. Surface integral curl f dot n vector n into ds. Here, what are the two things? Watch carefully. C is transformed in the positive direction, anti-clockwise direction we generally take. N is a, you must remember this. What is n? N is a unit outward normal vector. N is a unit outward normal vector at any point on the surface. So what we have to take? We have to take n as a unit vector in the outward direction at any point on the surface. Suppose this is the surface. So if we take in the suppose this is the surface. If we take in the outward direction, we take plus. If we take in the inward direction, we take minus. Outward direction plus, and this is outward direction. And if we take inward direction, we take minus for n. So n is a unit vector normal to the plane in the outward direction. And these are the basics you see here. We already know what is r is xi plus yj plus zk. If you differentiate, dr will become I dx plus y dy plus z dz. And the next thing is, when we do the problems, generally we will project the surface either on xy axis, xy plane, or yz plane, or zx plane. If we project xy on the xy plane, then ds will be dx dy by n dot k, because this is suppose xy plane. Suppose this is xy plane, then this will be perpendicular k. This is I, this is j, this is k. So always these three are perpendicular. So for xy plane, perpendicular will be k. For yz plane, perpendicular will be n I. Sorry, for x dx dy xz, the perpendicular plane will be j in the direction of y-axis. So what will be the for if we project the s surface on xy plane, then ds equals to dx dy by n dot k. Similarly, if we project the plane on surface on the yz plane, then ds equals to dy dx dz by n dot I. Here also ds equals to dx dy by n dot j. So let me try to do one question based on this method. Now watch here, see here. Verify Stokes theorem for f equals to x square plus y square into I vector minus 2xy into j vector over the rectangle bounded by the lines. See, I wrote the given vector f equals to x square plus y square into I minus 2xy into j. Let me first see what is this actually. This is the rectangle. Now let me draw how is the rectangle here. See, suppose this is the coordinate axis, x-axis, and suppose this is y-axis. Now watch carefully. The first thing is here we are having x equals to plus a minus a. Suppose we take minus on the left side. Suppose this is minus a, this is plus a. So this line is, suppose I am taking this line is x equals to minus a, and this line is x equals to a. And what are the lines? Y equals to 0 is nothing but x-axis. Y equals to 0 is nothing but x-axis. And y equals to b. Suppose this is y equals to b. So this line will be y equals to b. Y equals to b. So we got the rectangle here. This is in the mid. Okay. Now let's write the vertices also. Let me take the vertices as a, b, c, d. Now watch carefully how we can write. On x-axis we have to write y0. So this will be minus a0. And this is on the x-axis y0, a comma 0. This distance is a, so a comma 0. This distance is minus a, so minus a comma 0. And c. The x coordinate here is a, whereas the y coordinate is b here, so a comma b. and lastly this will be x is minus c and y is b here. So let me write this: a b c d be the rectangle rectangle with vertices. What we are taking vertices: a as minus a comma 0, b as a comma 0, c as a comma b, and lastly d as what we are having d, sorry, a b c, this is a d, so d as minus a comma b. So we got this vertices. Now see the next step. What we take r here, we know r equals to xi plus yj plus zk, but clearly the plane is given on the xy plane. We don't have z here, we don't have k here, so that means here z equals to 0. So what is left here? R equals to xi plus yj. Now if you differentiate, you will get dr equals to I dx plus j dy. So we got dr. Okay. Now next thing is, you see here, one more thing is here. What we can say, we can say that, okay, let me see that afterwards, one after one. First we have to go for the line integral. Now what is the formula? Let me first write the stroke formula. Strokes formula. Strokes theorem is line integration f dot dr over c equals to surface integral curl f dot n ds. Now watch carefully. First let me do the line integral. First let me solve the line integral, then we go for the curve integral. First we have to go for the line integral. Let me first find f dot dr. Let me first find f dot dr. So you see here, f dot dr equals to, f is given in the question as x square plus y squared I minus 2xyj dot dr. What is dr? Just now we find now. This is I dx plus j dy. What is the dot product? Dot product means multiplying the coefficients of I and coefficients of j. Now what are the coefficients of I here? X square plus y square into dx minus 2xy into dy. I coordinate coefficients, then j coefficients. So this is f dot dr. So for the line integral, let me go in the anti-clockwise series. First we solve along AB, then BC, then CD, then DA. Then we have to add along AB, then BC, then CD, then DA. So let me start. Now see here I'm writing along AB, along AB. Now what we have along AB, it is x-axis, so y equals to 0. So differentiate this will be dy equals to 0, y equals to 0, dy equals to 0. Now x goes from minus a to a, minus a to a. Now see here, the value of x is from minus a to a. This is x-axis, y equals to 0. If you differentiate, dy equals to 0. So let me substitute this in the f dot dr. Now see here, so let me substitute this. Therefore what we are having, we are having curve integration. See here, surface integration along AB, along AB, f dot dr equals to, what is AB? For AB we are having x equals to minus a to a, f dot dr. F dot dr is this. In this what we have to keep? We have to keep y0, dy0. If you keep dy equals to 0, this is 0. Y equals to 0 means this is 0. What is left? X squared dx. X squared dx. So integration of x squared is x cubed by 3. This will be minus a to a. Now we have to write upper limit minus lower limit. If you keep upper limit in place of x, it will be a cube by 3 minus lower limit means minus a cube by 3. So minus minus will become plus. This will become 2a cube by 3. 2a cube by 3. So let me note this here itself. Suppose let me write somewhere in the rough, because after we can add all this. So this integration of AB is, we got 2a cube by 3. 2a cube by 3. I wrote this in the rough because we have to rough this. So we have done along AB. Now let me continue. Now let we go along after AB, we go for BC. Along BC. Along BC. Now watch carefully. Let me see the figure what is here along BC. This is BC. So this equation, the equation of this will be, this line is parallel to y-axis. So its equation will be x equals to distance. Distance is this A. So the equation of BC will be line parallel to x-axis is y equals to distance. This distance is x equals to A. And from here, we go from y equals to 0 to y equals to B. X is constant here. Here also x equals to A, here also x equals to A. But here equals y is 0, y is B. So see here what we have to write now along BC. The equation of BC is x equals to A. Now if you differentiate this one, dx equals to, constant differentiation is 0. Now y changes from 0 to y equals to B. Now next step is curve line integration along BC, f dot dr equals to, what will be this value? Y equals to 0 to B. In this we have to keep x equals to, dx equals to 0 means this is 0. In place of x you write A. So this will be minus 2ay dy. So minus 2a. Integration of y will be y square by 2. Integration of y will be y square by 2. Now 0 to b. This 2 will get cancelled. So if you keep upper limit, it will be minus ab square. Minus ab square. Now if you keep lower limit, it will be 0. So therefore, integration along BC, we got this minus ab square. So let me note this integration along BC is minus ab square. Minus ab square. So next, let me take the next one along BC. Finish. Then we have to take along CD. Along CD. Along CD. Now see here. What is here along CD? Watch carefully. Along CD, this line is parallel to x-axis. Therefore, this formula is y equals to distance. This distance is b. So its equation will be y equals to b. And from here, x equals to a to minus a. Here x, we are going along c to d. So x equals to a to x equals to minus c. So let me take this one along CD. The equation of the line is y equals to b. Therefore, dy will be 0. Y equals to b, dy equals to 0, and x goes from a to minus a. So integration along CD f dot dr equals to integration x equals to a to minus a. In this, if we keep dy equals to 0, this will become 0. In place of y, if you keep b, this will become x square plus b square dx. Now integration of x square is x cube by 3 plus integration of b square is b square x, b square x. So we have to write this from a to minus a. See here, integration of x square is x cube by 3. Now integration of b square is b square x. Now we have to substitute upper limit minus lower limit. If you put upper limit minus a, this will become minus a cube by 3. If you keep x minus a, this will be minus a b square minus a b square. This is upper limit, minus lower limit means a. So a cube by 3. This will become minus a b square. So watch carefully. Sorry, this is plus, no? Plus. If you keep a here, a cube by 3 plus a b square. See here, minus a cube by 3 minus a cube by 3 will be minus 2a cube by 3. And minus ab square minus ab square is minus 2ab square. So let me wrote somewhere in the rough here. Okay, so what we are having, we are having integration of CD is minus 2a cube by 3 minus 2ab square, minus 2ab square. The last left, let me do the last one. Now see here, we lastly we have completed AB, BC, CD. Now along DA, along DA. Watch carefully. DA. What is this line? This line is parallel to y-axis. So its equation is x equals to distance means minus a. And from here to here y equals to b to y equals to 0. So let me take this equation. Line parallel to y-axis is x equals to distance is minus a. Sorry, we are taking along DA. X equals to minus a, and if you differentiate dx equals to 0, the last what we are having now, next one is we are changing y equals to b to 0. So let me lastly do this one. Integration along dA, f dot dr equals to integration y equals to b to 0. If we keep dx equals to 0, this will become 0. And if you put x equals to minus a, if you put x equals to minus a, minus into minus plus, this will become 2ay dy. Now 2a into integration of y is y square by 2 b to 0. This 2 will get cancelled. If you keep upper limit, it will be 0, minus if you keep lower limit, it will be ab square. So this is minus ab square, minus ab square. Now let me write all this, let me add all this. Now see, if we add this one, integration along AB, let me write add all these four line equations. AB integration plus, we can write like this, plus BC plus CD plus DA. The first one we got this answer, second one we got this answer, third one we got this answer, this fourth one. Now let me add this one. If you add this one, you see here plus 2ab cube minus 2ab cube cancel. This minus 2 minus 1 minus 3 minus 1 minus 4. So this will be minus 4ab square. Let note this as equation 1. So we have done the question by using line integral. Now the same we have to prove this by surface integration. So let we go for the surface integral. Let we go for the surface integration. So let me write, see what is the formula we are having. Let me start from here in the beginning. See here. Now see here, we have to solve using this. Now we already got the answer according to the line integration. We have to go for the curve integration. For the surface integral, first let we find curl f, then we find curl f dot n, then we go for the integration. First we find curl f, then curl f dot n, then integration. We go for the integration. So let me find curl f. We already know curl f means del cross f. Curl f means del cross f. What is del cross f? We have seen this in the previous classes. Del cross f means we have to take I, j, k. Del is dou by dou x, dou by dou y, dou by dou z. Now x, if you see f, this is here f. Here it will be x square plus y square. Here is minus 2xy. Here is 0. So this is del cross f. Let me solve this one. Now see here, equals to I into, we have to multiply this to 0 into a number 0, minus this. What is this here? Dou by dou z of minus 2xy. Now watch carefully. Okay, let me write one step. 0 minus dou by dou z of minus 2xy. Now in the next step, we have to take this minus j into, we have to multiply this to dou by dou x of 0 minus dou by dou z of x square plus y square. Lastly, plus k into, if you take k, we have to multiply this 2 minus this 2. So dou by dou x of minus 2xy minus dou by dou y of x square plus y square. Now let me solve this one. Sorry. Now see here, dou by dou z of 2xy, we don't have over here z, we have to differentiate with respect to z. We don't have z, so this is 0. So I into 0 will be 0 minus j into, this is also, you see, with respect to z, we don't have z here. This is also 0. Now what is left here? Plus k into. Now see here, differentiate with respect to x. Dou by dou x of x is 1. 1 into minus 2y minus 2y minus integration with respect to y. X square will be 0 because integration with respect to y, this is constant, y square is 2y. So what is left here? Minus 2 minus 2 minus 4y into k vector. So one step we got curl f. Curl f equals to minus 4y into k vector. Now we have, what is the next step? You see here, after curl f we have to find dot n. So what is n here? Watch here, n means the vector perpendicular to the plane. Clearly we are having the plane xy plane, so the perpendicular vector will be z axis. The plane perpendicular to xy plane is z plane, so this will be k. Along x-axis we take I, along y-axis we take j, along z-axis we take k, unit vector. So here n means k vector, n means k vector. See here, for xy plane, for the question given on xy plane, therefore we are having n as the unit vector is along z-axis, that is k. So what will be here? Curl f dot n equals to, curl f is minus 4yk dot n is k. K dot k will be 1. K dot k will be 1. So what is left here? Minus 4y. You remember this, k dot k will be 1. So 1 into minus 4y minus 4y. So also what is the formula of ds? Actually ds is dx dy by n dot k. But here we are having n as k. So if you keep here, k dot k will be 1. So actually ds is dx dy. ds dy. Now let me solve this one. See here, surface integral curl c curl dot f dot n, sorry, dot n ds equals to, you see here we have to take the limits. How the limits are there? X is from minus a to a, just now we have seen the figure. X is minus a to a, y is 0 to b, y is 0 to b. Now see here, once more I will explain. X is minus a to a figure, y equals to 0 to b, curl f dot n. What we got here? Curl f dot n, we got minus 4y. We can write minus 4 outside. What is left here? Y dy, then dx. Now integrate with respect to, watch here carefully, integrate, we have to integrate with respect to y. Integration of y will be y square by 4. Now what is left here? Minus 4 integration minus a to a, integration of y is y square by 2, 0 to b dx, 0 to b dx. Now we can cancel this one, 2 ones are 2 2s. So what is left here? Equals to minus 2 integration minus a to a. Now what is the formula? Upper limit minus lower limit. If we put upper limit, it will be b square, lower limit is 0. So left with b square dx. Now take out b square outside, minus 2b square integration minus a to a, here left with 1. So integration of 1 is x, minus 2b square integration of 1 is x minus a to a. Now again we have to substitute upper limit minus lower limit, minus 2b square into upper limit is a minus lower, again minus a minus 1 is plus a plus a 2 a, 2 2s are 4, minus 4ab square. Note this as equation 2. Now we already got the curl integration f dot dr also, minus 4ab square. So this we note previously as 1. So from 1 and 2 we can say that the line integration and the surface integration are same, minus 4ab square minus 4ab square. Therefore from 1 and 2 we can say that verify, no, the question, therefore we can say that Stokes theorem is verified. Stokes theorem is verified.